Today we'll be talking about how to name type 1 binary ionic compounds. Spoiler alert, yes, there will be a type 2, and we'll get to this in the next video. For this video, you'll need a periodic table. Pause the video if you need to go get one. Before we start, let's go over some basic vocabulary. An ion is an atom or molecule that has a net electric charge due to the loss or gain of one or more electrons. A positive ion is called a cation. A negative ion is called an anion. A cation is formed when an atom loses one or more electrons. An anion is formed when an atom gains one or more electrons. Here's a chart with the names of some common anions and cations. The superscript in the upper right-hand corner tells you the charge on the ion. For example, a 2+ means that the neutral atom it was formed from lost 2 electrons. A 3- means the neutral atom that the ion was formed from gained 3 electrons. Now get out your periodic table. Look at this chart and also look at the periodic table. What part of the table are most of the cations in? What part of the table are most of the anions in? Pause the video and look for patterns. See if you can figure this out. As you may have noticed, metal elements tend to form positively charged ions. Non-metal elements form negatively charged ions. A binary ionic compound is composed of 2 different ions of 2 different elements. The positive ion is almost always metal. The negative ion is a non-metal. Here are a few examples. When we name binary ionic compounds, we follow a set of rules. Rule number 1, the cation is named first and the anion second. Rule number 2, a monoatomic, which means one atom cation, takes its name from the name of the element. For example, Na+ is called a sodium ion. Rule number 3, a monoatomic anion is named by taking the root of the element name and adding "-ide" to it. For example, Cl- is called a chloride ion. Take a look at the table again. You should see this pattern. All of the cations have the same name as the element, though when we're talking about them in everyday chemistry speak, make sure you use terms like sodium ion or potassium ion so that you can tell we're talking about the ions and not the element. The names of the anions all end in "-ide, but we use the same convention when we talk about them in everyday chemistry speak. We say fluoride ion or phosphide ion. Because our cations are metals and our anions are nonmetals, you can expect a binary ionic compound to have a metal and a nonmetal in it. Pause the video and try using the rules to name the following binary ionic compounds, and then come back when you're done. Okay, so the first one, NaCl, is sodium chloride. K2O is potassium oxide. MgF2, magnesium fluoride. BaBr2, barium bromide. Li2Se, lithium selenide. And Ali3 is aluminum iodide. Here's a helpful hint. If you see the formula for a binary compound and you're not sure what kind of a compound it is, just look at the periodic table for guidance. If the first element is a metal, and the second element is a nonmetal, you're probably dealing with a binary ionic compound instead of a covalent compound, for example. And you can name it using the rules above. Okay, now let's talk about how we find the formula for a binary ionic compound if we're given the name. Although binary compounds are composed of two different elements, they can contain more than one atom of a given element. For example, sodium oxide contains two sodium atoms and one oxygen atom. If you are given the name of a binary ionic compound and you have to come up with the formula, you need to account for the charges on the ions. This periodic table shows the charges of some common cations and anions. I want you to look at each column one at a time. See if you can see some patterns, and then fill out the table in your notes pages. You can pause the video now and resume after you've finished your table. So you should have seen something like this. Now pause the video again and think about what general conclusions you can make about the charges of ions based on the data you collected from the periodic table. One pattern you should have noticed is that for every single group or family, for every single column, the ions have the same charge. So for example, the alkali metals in column 1, they all have a +1 charge. The alkaline earth metals in column 2 are all 2+. Now, if we go through the transition metals, we see quite a bit of variation. But when you go all the way to column 15, the nitrogen group, we have 3-. If you go to 16, the oxygen group, you have 2-. The halogens have a -1 charge, and the noble gases are neutral. They do not have any charge. Binary ionic compounds are neutral. That means they have no charge. So when you create the formulas for them, you have to do it in such a way that the sum of the total charges is 0. For example, let's find the formula for sodium chloride. We know the sodium ion will come first and the chloride second, so we'll write it on the board, but we'll leave a little gap. We'll write the charges above the ions. The charge on sodium is 1+, and the charge on chloride is 1-. If we combine the sodium ion with the chloride ion and add up our charges, +1 and -1, the sum of the charges adds to 0. Sodium chloride is therefore a good formula. Let's try another one, calcium bromide. The calcium ion is our cation, so it comes first. The bromide ion is our anion, so it comes second, and we leave a gap between them. First, we're going to write the charges above. Calcium is 2+, and bromide is 1-. So adding the two together, we get a +1 charge, which is not 0. So we need to balance this to make the total charge 0. So how do we do this? Pause the video and give it a try. We can make the formula neutral if we have two bromide ions. We'll write the subscript 2 here, and that's going to change our charge over the bromide ions to -2. So 2+ plus -2 gives us a net charge of 0. The formula for calcium bromide is therefore CaBr2. Note that we don't have to put a 1 subscript in for the calcium. Whenever we don't see a subscript, we just assume that there's only one ion. Let's do another one, calcium phosphide. We need at least one calcium cation. These have a charge of 2+, and at least one phosphide anion. These have a charge of 3-. But we notice that when we add the charges, the total charge is -1, and it's not neutral, so we have to balance. Pause the video and give it a try. Let's balance this. You may have noticed that if we had 3 calcium cations and 2 phosphide ions, we would have 3 times 2 plus, and that's 6, and that's 6 plus, and we'd have 2 times 3 minus, and that's 6 minus, and they both add to 0, which makes our formula neutral. So our final formula is Ca3P2. We are neutral. Here are some problems for you to try. Pause the video, then come back when you're finished working the problems. Here are the answers. Double check your work. If you got something different, then go back through your answers and see if you can find the problem. You should now know how to name type 1 ionic compounds and write the formula for a type 1 ionic compound. Stay tuned for next time when we will discuss type 2 ionic compounds.